Okay, 1.6 in Algebra 2 is sort of review, sort of new. It's kind of broken into 2 days. The first part's mainly review on linear inequalities. So an inequality is a statement that uses an inequality sign. Those signs are this: less than, greater than, less than or equal to, and greater than or equal to. Now these may look familiar. These are the different ways you might need to interpret and use inequalities. So determine if the following is a solution to the following inequality. Is 12.7 a solution to x plus 10 is greater than 21.4? So if we put in 12.7 plus 10 is greater than 21.4. 12.7 plus 10 is 22.7. So is 22.7 greater than or equal to 21.4? Yes. So is it a solution? Yes, because solutions make them true. So if it makes the inequality true, then it is a solution. And we'll check number 2. Is 9 a solution to 3x minus 5 is less than or equal to 22? So 3 times 9 minus 5 is less than or equal to 22. 3 times 9 is 27. 27 minus 5 is 22. So is 22 less than or equal to 22? Well, 22 is not less than 22, but it is equal to. So this answer is also yes. So just so you're aware, this little dash below here on these means equal to, less than or equal to. So it can equal or it can be smaller than. How we graph inequalities. To keep it simple, if we say like number 1, it says x is less than 7, I like to put a dash and put 7. You don't have to make a bunch of tick marks and start with 0 and go up to 7. Just put 7 in the middle. If it says x is less than and there's no equal sign below, that means it's going to be an open circle. So if I read this, it says x is less than 7. So think of your number line. Imagine there's numbers on here. It would go 7, 8, 9, and then over here would be 6, 5. Where are the numbers smaller than 7? They'll be smaller than 7 if you went to the left. So your graph will look like this. Open circle at 7, and it would go to the left because that's where the numbers are smaller. On the second one, we're going to put 4 in the middle of our line. Since we have this equal to sign below there, we're going to fill it in. So it's a filled in circle because it can equal 4. And now, if we read this, it says m is greater than or equal to, because it always opens up to the bigger one. So m is greater than or equal to 4. So the filled in dot means equal to 4. Where are the numbers bigger on a number line? The numbers get bigger to the right. So it would be an arrow pointing to the right. So that graph would show anything that is equal to 4 or bigger than 4. Okay, some properties. The properties of inequalities are the same as equations except when you multiply or divide by a negative number. That's when things are a little different. So if we look at this example, the first one says x is greater than 3. So let's pretend we multiply by negative 2. Multiply the left by negative 2 and the right by negative 2. We end up with negative 16 is greater than negative 6. Is that true? Is negative 16 greater than negative 6? No. So when we multiply by a negative, it actually made the inequality untrue. So if you multiply by a negative number, what we end up having to do is flip the symbol. and then it will be true. So you take the symbol and you flip it. So when you multiply or divide by a negative number, you have to flip the symbol, because otherwise it'll make it untrue. And then we're going to solve just two inequalities, and that's going to be it. So number one, negative 11y minus 9 is greater than 13. So we treat this like an equal sign. So you have to add 9, because we're trying to cancel out everything except for y. So negative 11y is greater than 22. And then we're going to divide by negative 11. So we divided by a negative number. If you divide by a negative, divide by negative 11. So flip symbol. So we would get y is less than negative 2. Again, if you divide by a negative, you have to flip the symbol. I don't like how this looks. I can't erase that now. So we flip the symbol. So now when we graph it, we're going to put negative 2 in the middle. If it says y is less than negative 2, less than means open circle. And where are the numbers smaller, to the left or right? Smaller goes to the left. So your graph would look like this. Open circle at negative 2 pointing to the left. In example 2, let's get all the x's over to the left. So here's our equal sign. We're going to add 2x to cancel out the minus 2x. And while we do that, just to save space, I'm going to get rid of this plus 5. So we have 5x is greater than or equal to 7. So we minus the 5 to cancel the 5, and we got the 2x on the left. Now we have to divide by 5. So since we are dividing by a positive number, we don't have to flip the symbol. We'll just have x greater than or equal to 7/5. Or you could say x is greater than or equal to 1.4. Either way is correct. So we're going to put 1.4 on our number line. If it's greater than or equal to, right? You see how it's greater than or equal to? It's going to be a filled-in circle because it's okay if it equals 1.4. And where the number is greater, the numbers are greater to the right. So it will look like this. Right, and we're going to stop right there. We just want to talk about how we graph the inequalities and how we can solve these inequalities. And we'll pick up on more tomorrow.